Welcome to Hot Topics. Today's subject will be what is the difference between demand and diversity type loads. Now, in the illustration that you see, we have four demand loads, and we're going to use a dwelling unit for these type of demands, but there are four here. And we're going to call out the cooking equipment that you see in the illustration, and we're going to use one and two ranges at less than 3.5 kW. We're going to use column A to table 220.55 that lists demand factors for ranges and cooktops and ovens. And that's on page 78, approximately, in your code book if you want to look it up. Now, with that in mind, we're going to go now to the next illustration, and you will see that we have in the boxed in information to the right at the top of the illustration, we have one 3 kW range, and when we go to our column A for less than 3.5 kW, which we're 3 kW, we're less, it's 80% for one. And when we do the math, it's 2.4 kVA. And we're just converting it to kVA from 3 kW. But notice it's reduced with demand of 80%. Now, demand loads, and demand is less than one, as you see in that 80%. If it's diversity, then we're going to be more than one, as we'll see. But now, let's look where we have two ranges, which is in the illustration. Again, we go to column A, table 220.55 on page 78 of the NEC. And for two ranges, we get a 75% demand. So we'd have 3 kW times two ranges, or cooktops, and we would have 75%, and it'd be 4.5. So now we have a 4.5 kW instead of 6 kW that we'd actually have there, see. So in step 2, we could convert that to volt ounce by taking 4.5 kW times 1,000, and we could convert it there, see. But notice the demand for one range or cooktop, 80%, and for two cooktops, it's 75%. Demand, less than one. Now, next we want to look at our next illustration, and our next illustration is going to be a diversity type load that we want to look at. Now, to look at that illustration, then notice what is given. We're considering four individual feeder circuits with connected loads of 250 kVA, 200 kVA, 150 kVA, and 400 kVA. And we're going to put demands on those of 90%, 80%, 75%, and 85% respectively. Now, going to the McGraw-Hill Electrical Engineering Handbook and look up the diversity for these type of loads, we come up with 1.5 based upon the type of loads. Are the loads total electric in the facility? Are the larger loads gas and everything else electrical? You know, those kind of loads that are presented are available in not a dwelling unit in this case, but a commercial or industrial site. Then that would determine what kind of diversity factor that you would use. You'd use a diversity factor here of 1.5. So now, calculating the demand for the feeder loads, then you'd have 250 kVA times 90%, 225 kVA. We would have then 200 kVA with 80% demand, 160 kVA. We'd have 150 kVA at 75%, we'd come up with 112.5 kVA. The 400 kVA at 85%, we come up with 340 kVA, and when we total it, we come up with 837.5 kVA. Now that is the sum of the individual demands equal to 837.5 kVA. Now, we can take that kVA rating and divide it by 1,000, and naturally we're going to come up with 837.5 kVA. So that feeder's transformer would be 850 kVA, the next size that we have selected. Now, using the diversity factor of 1.5, the kVA would equal 837.5, and we would divide that by 1.5. That would be your diversity factor from the McGraw-Hill Electrical Engineering Handbook, and we'd come up with 558 kVA for the main feeder. Now, the diversity of 1.5, we could use a 600 kVA transformer instead of having to use the 850 kVA by using a diversity factor. Now, in the NEC, why this became an issue and so many questions have come in about this subject, is that the NEC doesn't really call out diversity factors more than one. The NEC deals with demand factors less than one. So if you ever want to use, say, a diversity factor from a substation transformer supplying a facility at any location, always check with the authority having jurisdiction. Do your calculations, present that to the authority, and have the authority jurisdiction to approve it ahead of time in accordance with 90.4 in the NEC. But this is the difference. You have to keep in mind that demand factors are less than one, like 90%, 80%, and so forth. Diversity factors are greater than 1.5, 2.00, 2.5, and so forth. And it's based upon the type of loads that are in the facility that you select your diversity factor. I hope this is helpful to you and kind of explains it. But if you want more detailed information, just purchase the McGraw-Hill Engineering Handbook, Electrical Engineering Handbook, and it will give you more information pertaining to the subject. But this is the basic way it's calculated. You either have demand that you apply or you don't. You just have a straight load. Either way, you have your diversity factor that you can only select from the McGraw-Hill Electrical Engineering Handbook. Those diversity factors are not in the code. Well, good luck, and now you have it.